Okay, so we're going to look at the different forms of a quadratic. So if you look over here on the left, we have the first form is our standard form, the 2x squared plus 4x minus 30. In the second line down, we have our factored form, or what we call it, of intercepts form. And we have 2 times the quantity x minus 3 times the quantity x plus 5. And in the last one, the last box, we have vertex form, which is the A2 times the quantity x plus 1 squared minus 32. And that's vertex form because that tells us a couple things about the quadratic, most importantly, the x and y coordinates of the vertex. A couple things to note. I'm going to turn on these equations so you can see their graphs. So here's the first one. Then we turn on the second one, and it's the same graph. It just graphed right on top of it. And then the third one is the same graph again. So I chose these three because they are 3 versions of the same graph. You can see that I can write the equation for the same graph in the 3 different forms. Therefore, they are all equivalent. Some things to note in these equivalent forms. Notice the A for each one, the black one, the red one, and the blue one. All the A's are 2, and it's that multiplier out front. So that's going to be very important when you're converting. You want to know that those are all always going to be the same value. So if you have to convert from one to the other, you can kind of, what I say is like steal the A from the form you already have and use that same A in the other form if you need to. A quick recap. Standard form doesn't really tell us much about the graph. I mean, the A will tell us if it opens up or down. And the negative 30, the minus 30, the constant at the end, will tell us the y-intercept if you look here on the graph. Okay? But in standard form, you don't get much else. But that is standard form, and that is the graph of it. If we look at the second form, the red graph, so just for reference, I'm just going to leave the red one turned on. That's factored form. We also call it intercepts form because, again, you have the A, the 2, so it's telling you that it opens up. But then we have the factors x minus 3 and x plus 5, and that tells us the x-intercepts. So remember and recall that if the factored form is the factor x minus 3, then that's going to mean that the x-intercept on the graph is 3, 0. And if we have the form x plus 5, if we have that factor in the factored form, if we have the factor x plus 5, that means that the 0 or the x-intercept negative 5, 0 shows up on the graph. So I don't love saying this, but I know students recall that whatever factor you have, like an x minus 3, it's the opposite. 3, 0 is the intercept that shows up on the graph. So x minus 3 produces positive 3, 0. Okay? Then let's look at the last form here, vertex form. Again, note that the A is 2, so that tells us that the parabola opens upward because it's positive. Then we have the x plus 1. So much like the zeros, we take the opposite. The x plus 1 means that the x-coordinate of the vertex is negative 1. That's the x-coordinate of the vertex. Then the number that's just hanging out at the end, that constant, that minus 32, that is the y-coordinate of the vertex. So you can see that's why it's called vertex form, because we can get the x and the y coordinate out of both of those. So just some reminders. Another reminder you're going to use to your advantage is that we have, I should have put this on there earlier, but we have the axis of symmetry that runs right down the center of this parabola. And let's see, I'll make it a dotted line here. The nice thing about that is we know the parabolas are symmetric, and that axis of symmetry runs right down the middle. And what's nice is we know that the vertex, the vertex lies on that axis of symmetry. So the x-coordinate will be the average of the x's of the zeros. If I average the negative 5 and 3, those two x-intercepts, if I average those two numbers, I get the x value negative 1. So that is one way that we can also use that fact to our advantage here when we're about to do some work. And I'll remind you about these facts as we use them. All right, so I'm just going to kind of leave that over there for us to look at while I do some of this work. All right, so we have here our forms in general term here. So I've got my ax squared plus bx plus c. There's my standard form. Here's an example of it, right? And this happens to be the one I'm using over in Desmos over there, right? And this guy here is the intercept form. So intercept form or factored form, you've got a bunch of factors times each other. Notice that this is degree 2, okay, because each factor is like a degree of 1. And if we were to multiply those out, which we're going to do today, you'll see that that produces a degree 2. I should note back here in standard form, that one's degree 2, which makes it a quadratic. And then finally in vertex form, this part, the squared here, is what's going to make it a quadratic. Again, notice the A is the same as the other A's. And here's an example. So again, that A shows up in all of them. So we're going to convert from one form to the other. And we're going to do a bunch of different versions, from standard form to factored, from factored to standard, and so on and so forth. Notice that like when I'm converting, the answers will be each other because these are the same ones. I wanted to stay consistent. So when I convert this one, which is in standard form, to factored form, the answer is going to turn out to be this right here. But like, how do we get to that? So let's look at it. All right, so convert from standard form to factored form. Well, we've done a lot of factoring, so that's what this is. We just have to factor this right side. So there's going to be other methods of factoring, but we're going to just do this particular one here. So first thing I notice is there's a 2 that's common. So I'm going to common factor out a 2 out of all those terms. So if I divide the common factor, positive 2, from all of these, what's left over is x squared plus 2x minus 15. I'm going to write that a little better, sorry. Okay. Now I look in the leftovers and see if I could factor further. So this is a trinomial inside of there, so we need to do FOTAP. I'm sorry for Miss Rozicki's students. I might mess this up because I don't do it the same way you do it, but I'm going to try. So we're looking for factors of negative 15, right? Because this guy here, the A, which is 1, times the C here, so negative 15. Factors of negative 15 that add to the middle term, the B term, which is positive 2. So again, I don't know if you write the factors of, whoops, I didn't mean to do that, the factors of on top or on the bottom, but that's how I think you do it, right? So numbers that multiply to negative 15 that add to 2. So we're looking for those two numbers. We're going to say, let's see, it looks like it's going to be 5 and negative 3, right? If I multiply those, I get negative 15, and if I add them, I get positive 2. Now, the nice thing here is we don't need to split the middle term because A is 1 after we've already factored out the 2. So I get x minus 3 and x plus 5. And that is now in factored form. Remember, there could be other types of forms, like so you have to do other versions of factoring. This one was a common factor that turned into a FOTAP. You could have a quadratic that's like a common factor that turns into a difference of squares. You could have just a straight difference of squares, something like this. We could have a trinomial where A is not 1 and a common factor doesn't work. So there's all these different methods. I'm not going to rehash them all in this video. Just know to convert from standard form to factored form, you have to factor the quadratic, okay? And so we see, like I mentioned, that the answer here in factored form was indeed this one because these are all equivalent. All right, let's look at a different thing. So if we want to convert from that same standard form, but this time we want to put it into vertex form, well, we need to know, we have the A. Here's where we can steal it. Remember I said the A shows up, right? We need the A, we need the H, and we need the K. We need these three things, all right? So I'm going to say in here, we need to find or need to know A, H, and K. And maybe it's a good idea to write out the form that we're trying to write. So it's A times the quantity X minus H squared plus K. So we need to fill in the A, the H, and the K. So the A, we're going to steal it. We know the A is 2. Now, where do we get the H and the K from? Well, we know that the vertex, the x-coordinate of the vertex, The formula for that we've learned is negative b over 2a, right? And right here in standard form, I know a is 2, I know b is 4, and I know c is negative 30. So if I do negative b over 2a, I'll get the x coordinate. Let me write this here. Let's say vertex. This is something we need to know. This vertex is negative b over 2a. That's how you get the x coordinate. And the y coordinate will be plugging that answer back in for x and solving for y. So this part looks a little complicated, but it's just a fancy way of saying whatever answer you got for x, just plug that x into the function and figure out what y is. That's what this is saying here. All right, so x equals negative b over 2a. So b we said was 4. So we have negative 4 over 2 times a. A is 2. So we get negative 4 over 4, which is negative 1. So now I know the vertex has an x-coordinate of negative 1. Now, to get the y-coordinate, I'm going to find f of negative 1. Okay, now this function doesn't have f of x, but it's a y, but it's all the same idea. So if I plug that value, negative 1, in for x, I'm substituting in negative 1 here for x, and I'm substituting in negative 1 in here for x. I'm going to simplify this, do the arithmetic, and find out what the y value is of that vertex. And that will work for any point on the curve. If you know the x value, you can plug it in to get its y value. All right, so if I plug in negative 1, it was 2 times negative 1 squared plus, I think b was 4, right? Yeah, 4 times negative 1, and then minus 30. So f of negative 1 is going to be negative 1 squared is 1, so 2 times 1, plus 4 times negative 1 is negative 4. So actually, we'll go minus 4 minus 30. So f of negative 1 is 2 minus 4 minus 30, which equals negative 32. So then that becomes the y-coordinate of the vertex, negative 32. So now I have the other two pieces of information I need here. So I'm going to highlight that information. That is the h and the k that we need over here. So the h, let me write it underneath so you have that, or on top. That's the h, and that's your k of your vertex. So h is negative 1. So minus a negative 1, I can write it as a plus 1, right? And then minus 32 plus a negative 32. So that will turn into, this part right here will turn into minus 32. And that would be your vertex form. So what you're going to do, just to recap that one, is you need a, h, and k. H and k come from the vertex, the coordinates of the vertex. So you have a little formula here. This is important, right? To find the x-coordinate of the vertex. And then once you have that x-coordinate, you plug it into for x into your standard form and solve for y to get the y value of the coordinate. You plug them both in here, and of course you steal, sorry, I shouldn't say here. You plug them both in here and here, the x and the y, and then of course you steal the a from the front of the equation here and put it in here. All right, and you can see that that is our answer, as we said up here. Over here. All right, now we're going to go from factored form to standard form. Okay, so if it's already in factored form and you want standard form, you basically just multiply everything out. So, I don't know why I do it this way, but this is what I do. You got three things to multiply together. 2 times x minus 3 times x plus 5. Multiplication is a binary operation. That sounds fancy. It just means you can only multiply two things together at once. So I can multiply the 2 times the x minus 3, and then take that answer and multiply the answer times x plus 5, or I can do this in any order I like. I'm saying, I don't know why I do it this way, but I like to multiply these two together first. I like to multiply the x minus 3 times the x plus 5 using distributive property. And then when I get that answer, just multiply the 2 to that answer. So let's take a look. I like to multiply the a out last. So these parentheses are going to hold my answer when I distribute. So first, I'm going to distribute this x to this x. So x times x is x squared. All right, then I'm going to distribute x to the positive 5. So it'll be plus 5x. I should have done this in color from the beginning. So when I did that red distributive property, we would get x squared in red. The red sort of looks like the orange. All right, then we're going to now multiply the negative 3. So this negative 3 gets multiplied to the x. And then we're going to multiply the negative 3 to the 5. All right, and then we're going to combine any like terms. Uh-oh, now my iPad's freaking out. Y equals 2 times x squared. I can combine the 5x and the minus 3x to be plus 2x minus 15. So this is the result from multiplying out these two binomials. I still have that 2 hanging out, so now I can finally distribute the 2 to all these parts here. All right, and I'll make a new line up here. Y equals, if I distribute the 2 times the x squared, I get 2x squared. If I multiply the 2 times the 2x, I get plus 4x. And then the 2 times the negative 15, I get minus 30. And that is our final answer. Right, and you can see that was the standard form up here that we have. So going from factored form to standard form is just about multiplying everything out. Not too bad. All right, let's look at this one. Convert from factored form to vertex form. Yeah, I'll do this one next. So to convert from factored form to vertex form, let's look at what we know. So step 1 is like we know, so just consider what we know. We know A is 2, and we know the x-intercepts are 3, 0, and negative 5, 0. The reason those are important is we are, number 2, we're going to use the x-intercepts. I won't say use. Let's say what we're doing. We're going to average the x-intercepts to find the x value of the vertex. So, reminder, I know that my x-intercepts are here, and I know that the axis of symmetry runs right down the middle of those, right in between those two x-intercepts. So that x value that the dashed line runs through, that's going to also run through the vertex. So that vertex is like the average of the x value, I should say, of the vertex is the average of the intercepts. And that will happen on every single quadratic. So we use that to our advantage. So in this case, we have the x-intercept, just the x-coordinates we're working with now. We take the x plus the other x from the x-intercept. We're averaging, so we're adding them together and dividing by 2. That's how we average, right? So 3 plus negative 5 is negative 2 over 2, and we get negative 1. So we now know the vertex has an x-coordinate of negative 1. Okay? We find the y-coordinate the same exact way, so I should write that down again here. Once we have the x-coordinate, so on this form, I'll just say average the x-intercepts. I'll just say that. That's how you find the x-coordinate. And then f of average of the x-intercepts is how you find the y-coordinate. That just means it's fancy for saying once I have this answer, this over here to get the y, I just plug that average in or whatever that number was. So in this case, it was -1. So now we're going to plug -1 back into this equation. And there's 2 spots for x here. So we're going to plug that -1 in both spots. And be careful here. We're not adding the results together. Remember, we're multiplying 2 times whatever the result of this number is times whatever the result of that number is. So let's go ahead and do that. So we got y equals, and we're plugging in -1 for x. So -1 minus 3 times -1 plus 5. So we get y equals, let me see here, sorry. Y equals 2 times -1 minus 3 is -4. And -1 plus 5 is +4. So when we multiply these together, -4 times 4 is -16, times 2 is -32. So that's going to be the y-coordinate of our vertex, -32. Okay? Now, if we remember, our vertex in vertex form shows up as the h for the x-coordinate and the k for the y-coordinate. So that was step 2, average the x-intercepts to find the x value. I'll say that this is step 3. Plug that x value in to find the y value. And then step 4, write the equation. So remember, it's y equals a times x minus h squared plus k. That is our vertex form. You have to know the form, obviously, to do this. All right, so where do we get the a from? Keep in mind, that's the fun part there, too. It's kind of like the easy part. The a's are all the same in all the forms. That's going to always be true. So I can just snatch the a, like right here. This a gets stolen and goes right there. So we have our 2. Then my h was -1, so x minus -1 squared. Remember, minus a -1 or minus a negative becomes a plus, and then plus a -32. And remember that plus a negative becomes just minus 32. All right, and then lastly, so then lastly, we're going to convert from vertex form to standard form. And this one's interesting because it's pretty much just like example 4. You'll see once I write it out, except at the end, you got to subtract this constant or add this constant here. So watch what happens. So we're going to say again, just multiply. I'm going to say what you do is you multiply it out and combine like terms. So the nice thing that happens here, I'll summarize that afterwards. Let's look at how we write it out. The first thing is, how do you deal with the squared? You cannot just square both. This is bad. A lot of students will try to do this. They'll say, well, I just square the x and I square the 1. So x squared is x squared. 1 squared is just 1, and boom, I'm done with that part. That is not correct. That is not what you do. Okay, this is how you square a binomial. A binomial means, right, it's got 2 terms. This is how you square a binomial. You multiply it by itself. So, this part right here, this front part, is 3 things times each other, just like this was up here. So it's pretty much the same process. And by order of operations, I got to do all this multiplication out first, all 3 of these things, before I can subtract the 32. So that's just going to hang out at the end here always, minus 32. All right, and I'll do it right at the end. So again, I'm weird for some reason. I like to do the x plus 1 times the x plus 1 and keep that result in those parentheses. I like to do that first. So I'm not going to color code this one. I think we can do distributive property. I'm just going to do it. So x times x is x squared. X times 1 is 1x. Now I distribute the 1. 1 times x is 1x, and 1 times 1 is 1. All right, I notice I have 2 like terms here I can combine. So I multiplied these 2 things together to get this result. Before I can subtract 32, now I've got to multiply the 2 times all 3 of these. So that 2 is going to distribute to all 3 places. All right, we're going to multiply the 2, multiply the 2, multiply the 2. We'll keep track of that up here. Y equals 2 times x squared plus 2 times 2x plus 2 times 1. Okay? And then don't forget, we have this minus 32 that's just been hanging out. So I got to throw that at the end. Okay? Finally, I can combine them. I can subtract the negative 32. So I've got, whoops, I thought I had the laser pointer on. I've got these two like terms here. So I combine those 2, positive 2, minus 32 gives me a negative 30. All right, so there it is in standard form. So the nice thing about going to standard form, no matter which form I'm in, if I'm converting to standard form, basically the rule is just multiply it out. Notice I just multiplied it out. Here, I just multiplied it out. The only difference with this one is when it's in vertex form, I have that minus 32 hanging out at the end. So after I multiply it out, I just have to subtract the negative 32, and there we go. And that is it for our video.